welcome to Unit 3. And here in Unit 3, we are going to be talking about our rational numbers. We're going to begin with Lesson 2.1, page 46, and we're going to apply what we learned today to write fractions as decimals, decimals as fractions, and of course, we're going to put these numbers in order. Our essential question, how can you use a number line to order rational numbers? So ladies and gentlemen, please recall, it's very important that you are looking, listening, and learning first with your pens down, your markers down, and then when I am done, you go to the next page, you pause it, you actually write down all the information that you need to into your notes before continuing to listen to my voice talking about these rational numbers, ladies and gentlemen. So if you went to page 46, you already wrote some notes because that's what you're supposed to do before you start the notes. Get that mind working on what we're talking about. So you went to page 46 and you said, hey, it told me that rational numbers are numbers that are written in the form of A over B, where A and B are integers. Good thing we just learned about them. They're integers. And where B cannot be zero, no pun intended actually. So B is not zero. We learned about that in our last unit because we said, hey, if B is zero, it's zero would be in the denominator of that fraction, then we actually have an undefined number, right? Well, because we're going to be doing our rational numbers, you probably realize that rational numbers are fractions because A over B looks like a fraction. And then part of what we're doing today is taking those fractions and turning them into decimals. So decimals are also rational numbers. And if we take that A over B and turn it into a decimal, our decimal has to be one of two things. Our decimal has to either terminate or it has to repeat. A terminating decimal would be like, hey, if I have the fraction of 1/2 and I turn that into a decimal, then it would be 0.5. It doesn't go any further. It's terminated. It's ended. There's no more numbers beyond. If it's a repeating, we got to put or there, or repeating, then if we have a fraction of 1/3, if I turn that into a decimal, I have 0.3, and that 3 goes on forever, so we represent that with bar notation. We say, hey, that's a repeating decimal. So those numbers would be rational numbers. Now I want to add just a tiny bit more to your notes. I'm going to go as fast as I can. Please don't write that down yet. You probably have that written down. But hey, I gave you tons of space. You're probably wondering why I gave you so much space. That's because I want you to write down the real number system. And you're going to do it when I'm done. So the real number system. The real number system consists of two types of numbers. The first one, and I'm only talking about this first because we're actually not going to talk about it more than me just saying it, is the irrational numbers, because we're going to talk about this in a different unit. So the irrational numbers are one type of real number, and the other one, you guessed it, we're talking about it today, is our rational numbers. And our rational numbers is a much larger set of numbers in the form that it's what we've been dealing with. You've been dealing with rational numbers since you started doing math, and there's probably only one irrational number that you've really dealt with up to this point. But right now, we're talking about our rational numbers. And of course, we just learned about one group of rational numbers, that is our integers. That's our positive and negative numbers. So in the infinite negative direction, and then in the infinite positive direction, we have our integers. We learned all about those rules. By the way, those integer rules, I'm using air quotes, those integer rules apply to all rational numbers. It's just easier to learn them when we're talking about the positive and the negative numbers. Okay, before we start turning it into fractions and decimals. Of course, inside our integers is our whole numbers. And they started with 0 and then went infinitely in the positive direction. And then inside of our whole numbers, we have our natural or counting numbers. And they don't have 0, they just start with 1. And they go infinitely in the positive direction. So our rational numbers, of course, can be written in the form of A over B, or they can then be turned into a decimal, and they would either terminate or repeat. So you would have numbers like, okay, let's say 3/4. I turn that into a decimal, I would have 0.75, and of course that would be a terminating decimal. I could have, let's see, 1/9, and then as a as a repeating decimal, that would be 0.1 repeating. Now, of course, because our integers are negatives, our rational numbers can also be negative. So I could have a -1/2 and a -0.5 as a terminating decimal. These are all rational numbers. Now, I know some of you are probably thinking quizmically in your head, I'm going down to our natural numbers. And I'm taking this number. Well, we know 5 is in here somewhere. Mr. Ross, if 5 is a natural counting number, I know it's inside the rational numbers. It's called a rational number, but how can I write 5 in the form of a over b? Well, that's easy, ladies and gentlemen. You write it as an improper fraction with a 1 in the b spot. And then, of course, if I were then to turn that into a decimal, well, that would become 5.0. Now, I wouldn't write it up here. I write it down here because it actually fits into the natural counting number category. Make sense? All right. Copy all that down and then move to the next slide and join me for our first thing, that is the writing fractions as decimals. Thank you for joining me for writing a rational number as a decimal. So, ladies and gentlemen, you probably already know how to do this, because that fraction bar, we're looking at 6/5, number 1, represents division. So we take the numerator and divide it by the denominator. So I'm going to take 6 and I'm going to divide it by 5. Now, ladies and gentlemen, I always annex some zeros. I always annex 3 zeros. I never know how many I'm going to use, but that's what I do. And then for me, I always take the decimal up into the answer before I do anything. I recognize 5 goes into 6 one time. 1 left over, that gives me 10. 5 goes into 10 2 times. So my rational number 6/5 as a decimal is 1.2. Please watch example number 2 before you pause and write. In example number 2, -7 3/8, that's a mixed number. So, it's not in the form of a over b. I've got to put it in the form of a over b before I can turn it into a decimal. So I'm going to take and multiply 8 times it. Well, I kind of fibbed there. You can actually learn how to turn it into a decimal without making it into a over b. But I'm going to do a over b anyway. So 8 times 7 is 56, plus 3 is 59, so I have -59/8. Okay, now ladies and gentlemen, please remember that there is a study tip or some kind of tip on page 47 that says if I can have a fraction as integers, a over b is integers, then I can have negative a over b, I can have negative a over b, or I can have a over a negative b, and all of these would be equal. We can have all that. Anyhow, going back to our example number 2, I got -59. And I'm going to be dividing that, annex some zeros, by a +8. Then remember to put that decimal up into the answer. And now I know that 8 goes into -59. That's -7 times. Notice that that -7 matches the -7 of our whole number. Outstanding. Okay, so those 8 times 7 is 56. There's 3 left over. That would give me 30. 8 goes into 30 3 times. That's 24, 6 left over, 8 goes into 67 times, 56 gives me 4 left over, and 8 goes into 45 times evenly, so we're done. We have a terminating decimal, so as a decimal, -7 3/8 is equal to -7.375. Outstanding. Copy those down and join me on the next slide. Here we go with example number 3. We have a -3/11, and so I'm going to take that -3 and I'm going to divide it by 11, annexing some zeros, putting that decimal up into the answer. I recognize that 11 does not go into -3, so -0. But it does go into 30. It goes into 32 times. That's 22, and 30 minus 22 is 8. And so 11 goes into 87 times, 77, that's 3 left over, 30. 11 goes into 32 times, 22, looks like I need another 0. I'm going to go a little further. And that's going to give me 8 left over, and 7. Oh, I notice a pattern. 2, 7, 2, 7. So I now have a repeating decimal. And we learned that if I turn it into a repeating decimal, it is a rational number. So negative 3/11 as a decimal is negative 0.27. And I'm going to show that both of those numbers are repeating by putting the bar over both numbers. Outstanding. So, ladies and gentlemen, going on to example number 4. Once again, 1 and 5/27. Now, ladies and gentlemen, we talked about it a moment ago in example 2, where that negative 7 with that mixed number became the whole number. So if I want, I can recognize that my answer is going to be 1 point something. There's something that's going to come after it. That whole number becomes the whole number in my decimal. So you could do that if you wanted, instead of making it an improper fraction. It is up to you. So now I can take 5 and I can divide it by 27. Annex some zeros in there. Take that decimal up into the answer, and I recognize that goes in 0. And because I want to, I'm going to use my calculator. I'm going to go 5 divided by 27 because I know there's some big numbers. It actually 185, 185. And so I recognize that I have a repeating decimal, and there's 3 decimal places that repeat, 185, and I put my bar over that. So my final answer is 1.185 repeating. Okay? Outstanding, ladies and gentlemen. That does end the first one. We just turned our fractions into decimals. In this video, we're gonna do decimals to fractions and order them in our video number 2. Right here is your first quick write. 2 parts to your quick write. Go ahead and pause it. Get that quick write done. Take a short break, have a snack, talk to your mama, and then come back and join me for video number 2.